So, welcome to another lecture. In this lecture, we'll be doing a lot of trigonometric identities. What I've done is from the last 3 years sample papers of CBSE 2025, 24, 23 sample papers, I've selected a lot of good questions, which I found very interesting in trigonometric identities. Another thing which I did was I took trigonometric identities from 2025 board papers of CBSE. All these questions that you see, they have been taken either from the board paper or have been taken from the sample papers. And all these are good questions. You'll find them very interesting. And few of the questions you'll find difficult. And my suggestion to you would be to do these, to do the difficult questions again. Because you'll understand that you might find new techniques to do trigonometric identities. And one thing which I have been reiterating again and again during this lecture is that basically trigonometric identities is more a test of your algebra skills rather than your trigonometric skills. See, trigonometric identities are only three: 1 plus tan²θ, 1 plus cot²θ, sin²θ plus cos²θ. But this lecture would be more of your skills in algebra rather than trigonometry. So let's start. This lecture would be around 1 hour long, and if you watch this patiently, I promise you that you'll find a lot of interesting questions here. So let's start with an interesting question. Sin⁴θ plus cosθ is equal to x. Prove that sin⁴θ plus cos⁴θ is equal to 2 minus x² minus 1 whole square upon 2. See, there's one thing which I'll be repeating again and again during this long lecture, is that proving the trigonometric identities is less about trigonometry but more about the algebra. A lot of algebra is required, and it will help you a lot if you revise the algebraic expansions that you had done in class 9th. So a plus b whole cube, a plus b whole square, a minus b whole cube. So because we'll be doing a lot of algebraic manipulation. For example, in this question, I'll be using this identity, that a4 plus b4 is equal to a square plus b square whole square minus 2a square b square. Now, I understand this seems to be tough, but I'll spend some time, we'll be going step by step in understanding this question, because a lot of stuff would get clear. So we start with a simple expansion that x plus y whole square is equal to x square plus y square plus 2xy. That is the easiest one. Now, if you look closely at this, if I want the value of x square plus y square, then x square plus y square would be equal to x plus y whole square minus 2xy. So I have found the value of x square plus y square. Now in this, if I put x is equal to a square and y is equal to b square, see what happens. So my x is a square and y is b square. So this would be a square square plus b square square would be equal to a square plus b square whole square minus 2a square b square. Don't worry, I'm still on the question, but there's an expansion which I want to explain before I go forward. So this would be equal to a4 plus b4 is equal to a square plus b square whole square minus 2a square b square. So this is the expansion which I'll be using in this question, that a4 plus b4 is equal to a square plus b square whole square minus 2a square b square. How I'll be using this is, this is how I'll be using it. Here it is written sin⁴ plus cos⁴θ. So sin⁴θ plus cos⁴θ is equal to sin²θ plus cos²θ whole square minus 2 sin² cos²θ. Now, this is, how did I get this result? I got this result by using this expansion, that a4 plus b4, a4 plus b4 equal to a square plus b square whole square minus 2 a square b square. This is the expansion I'll be using when I will be using, when I have to understand what exactly is equal to sin⁴θ plus cos⁴θ. In this lecture, intentionally, the questions which I have taken are usually level 4 or level 5 problems. So If you don't understand any of the question, I request you to go through that question again and try to understand, because a lot of techniques will be learning. Now, sin theta plus cos theta is equal to x. How do I use this? Sin theta plus cos theta is equal to x. Squaring both sides. Sin theta plus cos theta whole square would be equal to x square. Oh, this is simple. Now I open this expansion. This will be equal to sin² theta plus cos² theta plus 2 sin theta cos theta is equal to x square. Now sin² theta plus cos² theta is 1 plus 2 sin theta cos theta is equal to x square. Therefore, sin theta cos theta would equal to x square minus 1 whole upon this 2. So this is the value of sin theta cos theta that I have found. So my sin theta cos theta is equal to x square minus 1 upon 2. Now this is what I will be using for getting to this result. But before that, I understand that sin⁴ theta plus cos⁴ theta, sin raised to power 4 theta plus cos raised to power 4 theta is equal to sin² theta plus cos² theta whole square minus 2 sin² theta cos² theta. Now, this part is equal to 1 minus 2 sin² theta cos² theta. Now, if I have the value of sin theta cos theta, then I can put it in this expression, And of course, I have the value of sin theta cos theta. Sin theta cos theta I derived here. So sin theta cos theta is equal to x square minus 1 upon. So let me put this value x square minus 1 upon 2 here. So my sin⁴ theta plus cos⁴ theta would be equal to 1 minus twice of, and here I'll put the value of sin theta cos theta whole square. Sin² theta cos² theta can be written as sin theta cos theta whole square. The value of sin theta cos theta is x square minus 1 upon 2. So this value is equal to x square minus 1 upon 2. I'll write it here. X square minus 1 upon 2. X square minus 1 upon 2 whole square. So I hope this is making sense. Finally, this would be equal to 1 minus twice of x square minus 1 whole square upon 2 square. And this would be equal to 1 minus, this 2 will get cancelled by this. So this will be equal to x square minus 1 whole square upon 2. So this is bit difficult question. You might have to look at the solution again. So now what I have proved is that that sin raised to power 4 theta plus cos raised to power 4 theta is equal to 1 minus x square minus 1 of whole square upon 2. Now let us look at the right side. What do they want? So it is 2 minus x square minus 1 whole square upon 2. I have got 1 minus x square minus 1 whole square upon 2. I've almost reached the solution. What I'll do is I'll again manipulate, and I'll write this as, I'll take 2 as LCM. So 2 minus x square minus 1 whole square. And this is what my RHS is. 2 minus x square minus 1 whole square upon 2. 2 minus x square minus 1 whole square upon 2. So as you look at this question, you will understand that a lot of manipulation is being required, and this is not a very simple question. You'll have to, unless and until you have practice questions like these, find it tough to directly do this kind of question in board exams. So, but the good thing is that there's a choice available. So this is a good thing. Otherwise, this question directly you try to do this in board exam becomes very difficult. So I'll just take you through the question again because we did a lot of stuff. I'll just spend some time to show you the solution again. The first thing that we did was we derived this result a4 plus b4 is equal to a square plus b square whole square minus 2a square b square. Now why did we derive this? Because usually we won't remember a expression like this, but this is what we'll require. If you remember this, well and good. And how did I know that I have to use this? Because I saw this sin⁴ plus cos⁴ theta. Once I saw this, I understood that this is the expansion that would be required. Then what I did was I have sin⁴ plus cosθ is equal to x. Then I manipulated this. This is how I manipulated it here. So I manipulated it here. This is the result which was given to me. I took it here and I found the value of sin⁴ cosθ. The value of sin⁴ cosθ is equal to x square minus 1 upon 2. Now this is the value x square minus 1 upon 2. This is the value which I will be using. Where? I'll be using this value in this expression sin⁴ θ plus cos⁴ θ. sin⁴θ plus cos⁴ θ is equal to sin²θ plus cos²θ whole square minus 2 sin²θ cos²θ. This I understand that this is equal to 1. This is equal to 1. Here, once I reach sin²θ cos²θ, I understand that this is equal to sin⁴ cosθ whole square. I have the value of sin⁴ cosθ. I put the value of sin⁴ cosθ here. This is the value of sin⁴ cosθ. I square it. I multiplied by it by 2 and I put 1 here. Why I am doing this? Because this is 1 minus 2 sin²θ cos²θ. Then I manipulated this x square minus 1 whole square upon 2. See here, one thing that you need to understand, if I have something like this, that 3 upon 4 this time. If I have a fraction like this, 3 upon 4 whole cube, this can be written as 3 cube upon 4 cube. If I have an expression like this can be written as 3 square upon 5 square. So this square can be broken into numerator and denominator. So this square, I use this square here and then I used it here. Then this was a 2 and this became 2 square, and this 2 and this 2 cancelled and only 1 2 remained. This is here. 1 minus x square minus 1 whole square. I took the LCM 2 minus x square minus 1 whole square upon 2. This word was equal to the right hand side. So I've spent some time explaining this question because interesting question, less of trigonometry and more of algebra. Let's move to the next question. So when I look at an identity like this, if I have to prove identity like this, one thing that strikes me is that there are a lot of tan theta, cos theta, cot theta, secant theta, cosecant theta. So to simplify the matters, to look at this identity clearly, what I try to do is at least on the left hand side. So I'll start with the left hand side. What I'll try to do is I'll try to reduce this cot theta to tan theta, so that there are less number of these to deal with. So the first thing that we'll do is we'll reduce this cot theta to tan theta, so that on the left hand side we'll only have tan thetas, and then we'll try to understand what is happening. So tan theta as it is, cot theta I'll write as 1 minus tan theta, 1 upon tan theta, sorry. So I've written this cot theta as 1 upon tan theta. Cot theta I'll write it as 1 upon tan theta. And this is 1 minus tan theta, this would be as it is. Now another thing which I've realized when I'm doing identities with my students is that identity is less about trigonometry but more about algebra. So there are a lot of algebraic expansions which will be required. So for example, in this question we might be using this expansion, and also there will be a lot of algebraic manipulation which will be required. So please don't assume that trigonometric identities is only about identities. It is a lot about algebra also. So it will help you a lot if you review the expansions like a cube minus b cube. You can have a look at the expansion of a minus b whole cube also. You can have a look at the expansion of something like, say, complex manipulations like a4 minus b4 is equal to. So what I'm trying to say is, please have a look at the algebraic expansion also. At least the common one you should be aware of. So let's proceed. So the numerator is tan theta, and the denominator, I will take tan theta as the denominator. So this would be tan theta minus 1. And this would be 1 upon tan theta 1 minus tan theta. So for example, if you are not aware of, if your algebra is weak, then you will find difficulty in coming to this step. And that is my point, that trigonometric identities is a lot about solving, be comfortable with algebra also. So here the manipulation that we'll have to do now is that this tan theta would come here. This tan theta would come here. So I'll write it as tan²θ upon tan theta minus 1 plus 1 upon tan theta 1 minus tan theta. Now, I'll just give you a hint. I won't go into detail because this would be another lecture. I've seen students get very confused when they have an expression like this. 1 by 4 by 7. Now, how you can write this as, how you can see this as is 1 by 4 divided by 7. So this would be equal to 1 by 4 multiplied by 1 upon 7. This would be 1 upon 20. If this was 4 divided by 1 by 7, then I would have written this as 4 divided by 1 by 7 to be equal to 4 multiplied by 7 equal to 20. So, in short, you should be aware of how to manipulate numerator and denominator, because that is what I have done here. So, for example, this tan theta, why did I bring it here? And this tan theta, why did it go here? Now, for that, you'll have to have a fair amount of understanding of how the numerator and denominator are manipulated when there is a division sign. And I'm emphasizing this, that I have seen a lot of students who struggle with this manipulation. And because all the identities that we'll be doing in this lecture, they'll be difficult identities. So you'll have to, maybe few of the students might struggle with few of the steps. So now we have tan theta minus 1 here and 1 minus tan theta here. So what I'll try to manipulate is, I'll try to make this as tan theta minus 1. How can I do that? By taking minus out. So I'll write this as tan²θ upon tan theta minus 1. I'll bring the minus out and I'll write this as tan theta minus 1. Again, algebraic expression, what I have done is, basically what I have done is, I have written 1 minus tan theta. I've taken the minus out and I've written this as tan theta minus 1. This is the manipulation I have done. And this minus is this minus. And the remaining is tan theta minus 1, which is written here. So now I have to take LCM of this expression and LCM of this expression. Now, see, the easier way of taking the LCM might be that what you can try to do is, you can multiply the numerator and denominator by tan theta. So what I mean is, you can write this as tan³ theta upon tan theta minus 1 minus 1 upon tan theta minus 1. So see, what I have done is, here the numerator and denominator are multiplied the numerator and denominator by tan theta. Why tan theta? Because I want this denominator to be equal to this denominator. Hope this is making sense. This is for the students who find it difficult to take LCM of algebraic expression. So this is another way of looking at things. But if you are okay, taking LCM of this and this, then you can skip this step. So I'll write this as tan theta minus 1. Tan theta minus 1. I'll write this as tan³ θ minus 1. Because here there is only 1. And now this expression reminds me of a³ minus b³. Right? Because this 1 can be written as 1³. And this is equal to a minus b into a square plus ab plus b square. I'll repeat again. All these questions require a lot of manipulation, because all the identities that I'll be covering in this lecture would be level 3, level 4, level 5. They are not so easy. So tan theta minus 1, and if you find them easy, well and good, very good. tan² θ plus tan theta plus 1 whole upon tan theta minus 1. Hope this makes sense, because now what I've done is, see, this is my a in this case would be tan theta, my b in this case would be 1, and I've just put a and b here. This would be a square, this would be ab, and this would be b square. So you are following. Any step that you don't follow, please mention in the comment. I'll answer back. Now here, if you see, tan theta minus 1 and tan theta minus 1 cancels. So this would be equal to tan² plus tan theta plus 1 whole upon tan theta. So I've reached here. But where do I want to reach? I want to prove this as 1 plus secant theta cosecant theta. Okay. So let's move ahead. So this can be written as tan theta plus 1 upon tan theta. Hope this steps make sense, because if it doesn't make sense, so because I've skipped a step, you can write this as tan² upon tan theta plus tan theta upon tan theta plus 1 upon tan theta. So this would be equal to tan theta plus 1 upon tan theta. So this is the 1. So I've got the 1. Now the rest of the 2 should be equal to secant theta cosecant theta. So this 1 I have arrived. Let me write this as a tan theta as a sine upon cos. Let me write this as sin theta upon cos theta plus cos theta upon sin theta. Why am I doing this? Because I want the answer to be in terms of secant and cosecant, and it's easier to see this in terms of sine and cos. So something will happen. Let's hope something happens. Now the LCM would be cos theta sin theta, and this cos theta, so this would be sin²θ plus sin theta, this would be cos²θ. So what we have arrived at is sin²θ plus cos²θ is 1. So this is cos theta sin theta. This would be equal to 1 upon secant theta cosecant, and this is equal to the right answer. So all the questions that I'm doing are a bit difficult. So, but you face any difficulty, any of the steps, please mention in the comments, and I'll answer back. Let's move to the next question. So let's move to the next question. 1 plus sin² theta is equal to 3 sin theta cos theta, and prove that tan theta is equal to 1 or half. Now, see, when I look at this tan theta, I get some clue about what might be happening. So what I do is I take this 1 plus sin² theta, 1 plus sin² theta is equal to 3 sin theta cos theta. I divide the left hand side and the right hand side by cos² theta. And let's see what happens next. So this will be equal to 1 upon cos² theta plus sin² theta by cos² theta would be equal to 3 sin theta by cos theta. 1 upon cos² theta is equal to secant² theta plus tan² theta equal to 3 tan theta. Now, slowly you will understand that this is becoming a quadratic equation. Why? Because 1 plus tan² theta equal to secant² theta. So, I can replace this secant² theta by 1 plus tan² theta. So, this will become 1 plus tan² theta plus tan² theta would be equal to 3 tan theta. So, this will be equal to 2 tan² theta minus 3 tan theta plus 1 is equal to 0. What I have done is, I have taken this tan² theta plus tan² theta, this is 2 tan² theta. This 3 tan theta will come on the left hand side and this is 1. So, 2 tan² theta minus 3 tan theta plus 1 is equal to 0. So, this is basically a quadratic equation. Now, just to make it simple and repeating tan theta again and again, let me replace tan theta by x so that x is because simpler to write. So I'll write this as 2x square minus 3x plus 1 is equal to. As you can see, this is a quadratic equation. So minus 2. So I can write this as 2x square minus 2x minus x plus 1 is equal to 2x is common. So x minus 1 equal to 0. This will be equal to 2x minus 1 and x minus 1 is equal to 0. Therefore, x is equal to half or x is equal to 1. Now my x was actually tan theta, which implies tan theta equal to half or tan theta is equal to 1. And that is what needs to be proved, that tan theta is equal to 1 or tan theta is equal to half. Okay, minus 1 cos a minus sin a plus 1 is equal to cosec a minus cot a. So frankly, this is one of those questions which if you are directly doing in the examination, you will find it difficult to solve. These are the kind of questions which if you have practiced and if you have met before, these are the kind of questions you can solve only then, at least for an average student, unless and until you are very intelligent. So there's a typical way in this question is solved. So what I'll do is I'll divide the numerator and denominator by sin a. And then let's see what starts happening. So I take the numerator, I divide whole of the numerator by sin a. I take the denominator, I divide whole of the denominator by sin a. So cos a upon sin a plus sin a upon sin a is 1. This is 1 minus sin a. Cos a upon sin a minus 1 and this is 1 upon sin a. So cos upon sin is equal to cot a. Why am I doing this? You will understand in a while. So this is cot a plus 1 minus 1 upon cosec a, and the denominator would be equal to cot a minus 1 plus 1 upon cosec a. This is the denominator. Now what I do is I take the numerator cot a minus cosec a, I pair it like this. This is my 1 is written here, and cot a plus cosec a is written like here, like this, and this minus 1 is here. Now I remember that 1 plus cot cot²a is equal to cosec²a. Now what I'll do is, the manipulation that I do is I understand that 1 plus cot²a equal to cosec²a. So what I'll do is I'll replace this minus 1, this 1 by cosec²a minus cot²a. And why do I do that? You'll just understand in a while. So the numerator remains same. So it's cot⁴ minus cosec² plus 1 whole upon cot⁴ plus cosec². This is one term, and minus this 1, I'm replacing it by cosec² minus cot². Cosec² minus cot². Now, why do I do this? You'll understand in a while. See, if I look at my cosec² minus cot² term, I can write this cosec² minus cot² as cosec² plus cot⁴. So let me show you the denominator. I'll just focus on the denominator. So cot⁴ plus cosec² minus cosec² plus cot⁴ multiplied by cosec² minus cot⁴. So I'm just manipulating the denominator. This is, please see that this is just the denominator part. Otherwise, it will create huge mess. So I'm not writing the numerator now. So now my denominator, what does my denominator become? This cosec² plus cot⁴ is common. So I take the cot⁴ plus cosec² as common. This will be equal to 1 minus cosec² minus cot⁴ bracket close. So cot⁴ minus cot⁴ plus cosec² and cot⁴ plus cosec², this is a common. So I have taken common. I will leave a 1 here and minus cosec² minus cot⁴. See, again and again, what I'm trying to tell you is that trigonometric identities are more to do with your algebraic skills rather than trigonometry, because a lot of manipulation would be required, and usually these kind of tough questions don't come in the exams, but it is better that you practice. And like if you are looking at this solution, you can look at the solution once or twice. You try to practice this question twice, thrice, 4 times. Just learn the techniques, how the algebra is manipulated. That is important, especially for students who will be taking maths in grade 11 and 12 also, because these are the identities which will come in grade 11 also, trigonometry also. So that is why it is suggested. So this is what my denominator has reduced to, and if I compare this with my numerator, you'll see what will happen. Now let me bring my numerator back. My numerator is cot⁴ minus cosec², cot⁴ minus cosec² plus 1. Now my denominator is cot⁴ plus cosec² multiplied by multiplied by 1 plus cot⁴. This minus and this minus, 1 plus cot⁴ minus cosec² minus cosec². Now if you look carefully, you will see what magic happens. So 1 plus cot⁴ minus cosec², 1 plus cot⁴ minus cosec². So this one and this one will cancel. My answer would be 1 upon cot⁴ plus cosec². What is that I require on the right hand side? It is cosec² minus cot⁴. So Let me write this as 1 upon cot A plus cosec A multiplied by cosec A otherwise I'll run out of space. So 1 upon cot A plus cosec A multiplied by, this is cosec A minus cot A. So I'll write it as cosec A plus cot A on cosec A minus cot A. So this will be cosec A minus cot A whole upon, this is A minus B into A plus B. So this will be equal to cosecant square A minus cot square A. Hope this is making sense. And we understand 1 plus cot square A equal to cosecant square A. So cosecant square A minus cot square A would be equal to 1. So basically my denominator, this denominator is actually equal to 1. So my final answer would be cosec A. So as told before, this is a bit difficult question, and it helps if you do this question twice or thrice. So my first step was I divided the numerator and denominator by sin A. The numerator and denominator by sin A. See, this is what I did. I divided the numerator and denominator by sin A. Then what I did was I made pairs. This is how I made the pairs. Cot A minus cosec A plus 1 and cot A plus cosec A minus 1. Then I replace this 1 by cosec square A minus cot square A. This 1 by cosec square A. This is what I did. Cosec square A minus cot square A. Again, I took the denominator. I did some algebraic manipulation, and what I did was I took the cot A plus cosec A out, and inside it was 1 minus cosec A minus cot A. Then when I wrote the denominator back and I brought the numerator back, cot A minus cosec A plus 1, what I realized was that the numerator would cancel. This is equal to 1 upon cot A plus cosec A. Then I multiplied the, basically what I did was I took the denominator multiplied by cosec A minus cot A. Numerator and denominator is the same. Basically this whole of this equal to 1. The numerator and denominator is same. So cosec A minus cot A upon cosec square A minus cot square A. Cosec square A minus cot square A is equal to 1. Therefore, finally I got cosec A minus cot A. So this is my right hand side. So interesting question, and bit of difficult question. You will have to do this question at least 3 to 4 times. And this is the kind of question you should keep in mind. This is the kind of question which comes, then a lot of algebraic manipulation would be required. Let's move to the next. Let's move to the next question. Sin theta plus cos theta is equal to root 3. Prove that tan theta plus cot theta is equal to 1. Again, one of the interesting questions like we did before. We did this question before. So again, a very interesting question. So sin theta plus cos theta is equal to root 3. Now, similar to what we did last time, squaring both sides. We did the same thing in the last question also. So sin²θ plus cos²θ plus 2 sin theta cos theta equal to 3, because when I square root 3 it becomes 3. Sin²θ plus cos² would be equal to 1. 1 plus 2 sin theta cos theta equal to 3. Now if I solve this, then sin theta cos theta, so 3 minus 1. So I'll have a 2 here. 2 sin theta cos theta, 3 minus 1 is equal to 2. Therefore, sin⁴ cosθ will be equal to 1. This is the value of sin⁴ cosθ that I have found. Now let me look at the right hand side. So my right hand side, what I need to prove is tan⁴ plus cosθ is equal to 1. I need to prove tan⁴ plus cosθ is equal to 1. So I can write tan⁴ plus cosθ as sin⁴ upon cosθ plus cosθ upon sin⁴. This is cosθ sin⁴. So cos, this will be sin²θ plus sin⁴ sin⁴. This will be cos²θ. So this will be equal to 1 upon sin⁴ cosθ. And I have found the value of sin⁴ cosθ as 1. So this will be equal to 1. So tan⁴ plus cosθ equal to 1. So this is how this question is done. Similar to this question. In this question also we had done something like these. These are the questions which are very good to practice before you plan to appear for the board exams. Let's move to the next question. Cos⁴ minus 2 cos³ θ upon sin⁴ minus 2 sin³θ plus cot⁡θ is equal to 0. So let's have a look at this question. So cos⁴ minus 2 cos³θ, cos⁴ minus 2 cos³θ upon sin⁴ minus 2 sin³θ, sin⁴ minus 2 sin³θ plus cot⁡θ. Now, when I look at this question, it's pretty obvious that I need to take cos⁡θ common from the numerator. So 1 minus 2 cos²θ on, and from the denominator I'll be taking sin⁴ as common. Sin⁴ upon 1 minus 2 sin²θ. For a while what I'll be doing is I'll be ignoring this term. I'll be taking this term after a while. I'll be focusing on this term only. Manipulation of this term only. So now this one and this one, I will write this one as sin²θ plus cos²θ. Cosθ. I will write this as cos² plus sin² minus 2 cos² on sin⁴ cos² plus sin² minus 2 sin²θ. So now you might ask, why did I do this? I did this because I can see some cos² and sin² here. So that is why I manipulated this one as cos² plus sin²θ. Now how does this benefit me? Let's see. So this is minus 2 cos². This is plus cos². So I'll have something like cosθ in sin² minus cos². Whole upon, I see minus 2 sin² here plus sin² here. So sin⁴ upon cos² minus sin²θ. Now this is a square minus b square. A square minus b square, I know this is equal to a plus b. So cosθ into sin⁴ plus cosθ. Sin⁴ minus cosθ. Whole upon sin⁴. Cosθ plus sin⁴ multiplied by cosθ sin⁴. Now, if you look carefully, this sin⁴ plus cosθ, this sin⁴ plus cosθ will cancel with this cosθ plus sin⁴. And again, if you look carefully, this term sin⁴ minus cosθ and cosθ minus sin⁴ are same. The only difference is the minus. So what I can do is I can take a negative out from the first term. So from this term, I'll take the negative out. I'll take a negative out and I'll write this term as cosθ minus sin⁴. sin theta as it is, cos theta minus sin. Why do I do that? Again, I see that cos theta minus sin theta cancels to minus cot theta. Now, if you look carefully and remember what I did in the beginning, this whole term has been reduced to minus cot theta. This is minus cot theta. This one is cot theta. Whole is equal to, which is right hand side. So again, an interesting question, and let's move to the next question. So next question, 1 plus cosec A upon cosec A is equal to cos² upon 1 minus sin A. A fairly easy question. So all that I need to do is convert this cosec A as 1 upon sin A, cosec A is 1 upon sin A. So if I take left hand side, so I'll write this as 1 plus 1 upon sin A. 1 upon sin A. So sin A would be the LCM in the numerator. It will be sin A plus 1 whole upon 1 upon sin A. This would be equal to sin A plus 1 upon sin A multiplied by sin A 1. This will cancel and this will be equal to sin A plus 1. And so this is my LHS is equal to sin A plus 1. Now I'll take my right hand side. I'll write my cos²a as 1 minus sin²a. This is 1 minus sin A. So 1 minus sin²a, basically this is a square minus b square, and this will be equal to a plus b into a minus b. So 1 minus sin²a can be written as 1 square minus sin²a. This can be written as 1 minus sin A multiplied by 1 plus sin A whole upon 1 minus. So this will cancel. So my right hand side is equal to 1 plus sin A. So right hand side is equal to 1 plus sin A, and left hand side is equal to 1 plus sin A. So that is how I prove this identity. Let's move to the next question. So let's move to the next question. 1 plus 1 upon tan square, 1 plus 1 upon cot square is equal to 1 upon sin²θ minus sin⁴θ. Now, another thing that I keep discussing with my students is that when they look at trigonometric identities, they get so bogged down that it's almost like their mind stops working. But you'll understand that this is a fairly simple question. There are a lot of tan theta, cot theta, sin²θ involved, but it's a fairly simple question. Let's start this question. So this is the question. I've started with the left hand side. So 1 upon tan²θ, I'd write this as cot²a. This is theta, so I'll write this as theta. Sorry, I've written this as. So let me write this as theta. So the first one is 1 plus cot²θ. This is 1 upon cot²θ, so this is tan²θ. Hope this is making sense. Now I understand this is a standard identity. 1 plus cot²θ is equal to cosecant²θ. 1 plus tan²θ is secant²θ. So this is what I have arrived at, starting with the left hand side. Now if I look at the right hand side, see, I am getting a hint from the right hand side. If you look closely, I can take sin²θ out and I'll have 1 minus sin²θ. So this will be sin²θ, 1 minus sin²θ will be equal to cos²θ. So when I look at you keep looking at the right hand side, and the right hand side will give you few hints of itself that what does it want. So when I reach here, I understand that this can be written as 1 upon sin²θ secant cos²θ, and I had got the hint here. This cos²θ can be written as 1 minus sin²θ. So this can be written as 1 minus sin²θ. And this can be reduced to sin²θ minus sin⁴θ. This is equal to the right hand side. So what I'm trying to tell you in this question is, one thing that I've told you in this question is that please keep looking at the right hand side, what you want to prove, because what you want to prove will give you few hints. After every step of the left hand side, please keep looking at the right hand side also, because the right hand side will give you few hints. What does it want? For example, in this case, the right hand side wanted it to be something like sin²θ upon cos²θ. We started with the left hand side, but we realized that we already had got this. So that is the first thing that I'm trying to tell you. Second thing that I'm trying to tell you is that please don't get bogged down by all the tan, cot, sin²θ. Please don't get bogged down by that. There are times when the question looks very difficult, but it's easy. For example, this case, all I did was 1 upon tan square, I wrote as 1 cos²θ, 1 upon cos²θ as tan²θ. So this is what I started with. This is a step that this is the first step I did. Then I realized 1 plus cot²θ is equal to cosecant²θ. This is 1 plus tan²θ is equal to secant²θ. And then when I looked at the right hand side, I understood that this cosecant² has to be written in the form of sin². So this I wrote it as 1 upon sin²θ cos²θ. And then a manipulation of cos²θ, and finally I had the right hand side. Hope this is making sense. And let's move to the next question. Next question is pretty interesting. As a matter of fact, both these questions, they will require a lot of manipulation. So let's start. 1 upon cos⁴A minus cos⁴A, 1 upon sin⁴A minus sin⁴A is equal to 1 upon tan⁴A plus cot⁴A. Now I'll start with the LHS, the left hand side. If I look at the LHS, for the first term, the LCM is cos⁴A. So this will be 1 minus cos²A multiplied by the second term. Again, sin⁴A is the LCM. So this will be 1 minus sin²A. Now 1 minus cos²A is equal to sin²A upon cos⁴A. And this will be 1 minus sin²A is equal to cos²A. This will be sin⁴A. So cos⁴A and cos⁴A will cancel. Sin⁴A and sin⁴A will cancel. This will be equal to sin⁴A multiplied by cos⁴A. So this is what my left hand side of the identity is equal to. So I have reached here, but I need to reach here. So let me take the right hand side. Now if I look at the right hand side, let me break this tan⁴A and cot⁴A. Or what I can do is I can write this cot⁴A as 1 upon tan⁴A. So let me do that. Tan⁴A plus cot⁴A is 1 upon tan⁴A. If I take the LCM, it will be tan⁴A. This is tan⁴A upon 1. So this will be tan²A plus 1 upon 1 plus tan²A is equal to secant²A. So this will be secant²A upon tan⁴A. Let me take the reciprocal. This will be equal to tan⁴A upon secant²A. Now, if you look at tan⁴A upon secant²A, because I don't have space there, so let me write it here. So tan⁴A upon secant²A. tan⁴A upon secant²A. If I break this, this will be equal to sin⁴A upon cos⁴A multiplied by the secant²A would be equal to cos²A upon 1. So cos⁴A and this cancels. So this is equal to sin⁴A cos⁴A. So my right hand side is equal to sin⁴A cos⁴A. My left hand side is equal to sin⁴A cos⁴A. Both are equal. Therefore the identity is Basically, what I did was I took the LHS first. LHS I reduced it to sin A cos A. Then I took the RHS and I proved that the RHS is also equal to sin A cos A. And because LHS is equal to RHS, therefore the identities. So this is another way of proving the identities. Now let's move to the next question. It's a pretty interesting question. And let's start. This is the interesting question I found. So tan A is equal to √3, where A is an acute angle. Then find the value of sin²A 1 plus cos²A. I've seen this kind of question coming again and again in some way or the other. So sometimes they give the value of sine, sometimes they give the value of cos, and then you have to manipulate. See, this is a fairly simple question because if tan A is equal to √3, then you understand that A would be equal to 60 degree. Because they have mentioned that A is an acute angle. So once A is 60 degree, all that I need to do is I need to just put the value of A here. This will be sin² 60 degree upon 1 plus cos² 60 degree. And then you can put the values of sin² and cos² and then you can find the answer. So this is one of the easier question. Let's move to the next question. So let's have a look at this question. Now, this question is similar to what we had done in this question. These square roots will scare you, but it's a pretty simple question. Now, secant A minus 1, secant A plus 1, secant A plus 1, secant A minus 1. See, one thing that you need to understand, there's a simple rule that you need to understand. √2 multiplied by √2 is equal to √2 into 2. What this means is that, if there are same numbers that come under a square root, the answer is the number itself. So I'll be using this concept when I'll be doing this question. So let's start. Another thing that you can understand is for people who find difficulties in square roots, because I've seen a lot of kids face difficulty in square roots. So this is equal to √A upon root. So if there is a square root on a fraction, if there is a square root on a fraction, the square root can be broken into numerator as well as denominator. So for example, if you have something like this, square root of 4 upon 3 can be written as square root 4 upon square root 3. So this is something that I need to discuss before we start doing this question. And of course, another thing that I want to discuss is, yeah, that should be enough. Okay, let's start. So first I'll break this into 2. Secant A minus 1 upon secant A plus 1. So breaking the square root. Secant A plus 1 upon secant A minus 1. So I've broken the square roots. Now I'll take the LCM. How I'll take the LCM is, it will be secant A plus 1 multiplied by secant A minus 1. And now when I have to take the LCM, see this root secant A plus 1, this is root secant A plus 1. So I have to multiply this. I have to multiply this term with this term. And because the square roots, under the square root, the same number would be there. This is what I was trying to tell. So root secant A minus 1 into root secant A minus 1 would be equal to secant A minus 1. The same rule as saying root p into root. If we are multiplying the square roots of the same number, that is equal to the number itself. So this is done. Now let us look at the next term. So secant A minus 1, secant A minus 1. So here it will be root will be root secant a plus 1 into root secant a plus 1. This will be again equal to secant a plus 1. Now this minus and plus will cancel, and this will be equal to secant a plus secant a. This will be equal to secant a upon. So this is, if you look closely, this is a plus b into a minus b. A plus b into a minus b is a square minus b square. Will be, the root will remain, will be equal to secant square a minus 1. Hope this is making sense. Now when you look at this, we understand that 1 plus tan square a is equal to secant square a. So secant square a minus 1 will be equal to tan square a. Secant square a minus 1. So this is equal to tan square a. So I can replace this secant square a minus 1 by tan square a. So let me do it here only. Tan square a, and root of tan square a would be equal to tan a. So the square root will vanish. This will be tan a. Now again, if I look closely at this, 2 secant a can be written as 2 upon cos a whole upon tan a can be written as sin a upon cos a. Now this can be written as, let me make some space here. Again, a lot of students face difficulty when they see something like this, but this is very easy to understand. See, let me solve something like this: 3 upon 4 divided by 5 upon 3. So how do we solve this? We write this as 3 upon 4 divided by 5 by 3. This is just to explain. So 3 by 4 into 3 by 5, 9 upon 20. So basically, this fraction divided by this fraction would be equal to the numerator multiplied by the reciprocal of the denominator. So here it was 5 by 3, here I have written 3 by 5. So this is how these kind of divisions are handled. Now, as I have been discussing, see, proving the trigonometric identities, it is more to do with the algebra rather than trigonometry, because the trigonometry part is easy. It is the algebraic manipulation which gets difficult. So this will be equal to 2 cos a, the numerator, multiplied by the reciprocal of the denominator, cos a upon sin a. This cos a will cancel. So this will be 2 upon sin a, and this will be equal to 2 cosecant a. 2 cosecant a is what is equal to the RHS. This is equal to. So that is what I was trying to tell you, that this question and this question, they are almost the same. For this question also, you look the question, we did something like this. Finally, this was equal to 2 secant a. Scary. Both of these are scary looking questions, but if your algebra is fine, they can be done easily. And in trig identities, it's the algebra which is a core issue. It's not the trigonometry. So let's move to the next question. So let's look at the next question. Cosec theta minus 1, cosec theta plus 1, cosec plus 1, cosec minus 1 is equal to secant theta. Now, the interesting thing is this question and this question, the next question, they are almost the same, and they look very dangerous, but they are pretty simple questions. So let's start doing them. So first, we'll start with this. So cosec theta minus 1, cosec theta plus 1, cosec theta plus 1 upon cosec theta minus 1. So first, what I do is, just to simplify the matters, you can skip this step if you want. So just to simplify the matters, I am breaking the numerator and the denominator into 2 parts. Once I have done this, I'll take the LCM. LCM is cosec theta plus 1 divided by cosec⁴θ. See, one thing that I am commenting again and again is the trigonometric identities, they are more to do with your basics of algebra, your manipulation in algebra than trigonometry itself, because the identities are only 3 in number. So they are more to do with how good your algebra is. So for students whose algebra is weak, they will find all these manipulations a bit difficult. Cosec⁴ plus 1, cosec⁴ plus 1. So I'll have to multiply this by this. When I multiply, this root and root will cancel. I will have cosec⁴. Let me use the color. I'll have this one multiplied by this one. I will have cosec⁴ minus 1, because the root sign will, it's like multiplying root 2 and root 2. So root 2 multiplied by root 2 is 2. So this one is taken care of. Plus, now in the second case, what I'll have to do is, when I take the second term, cosec⁴ minus 1 root is already there. So cosec⁴ plus 1 root multiplied by cosec⁴ plus 1. Again, root multiplied by root would be, the root will vanish. So this would be equal to cosec⁴ plus 1. Hope this is making sense. Now when we look at the numerator, we see that this minus and minus will get cancelled. The numerator, I'll have 2 cosec⁴ upon. Now if I look at the denominator, this is a plus b into a minus b. A plus b into a minus b is a square minus b square. This would be under that square root sign. So this would be cosec² θ minus 1. Now I understand that 1 plus cosec² θ is equal to cot²θ. Let me write somewhere here. So I understand 1 plus cot² θ equal to cosec²θ. So cosec² θ minus 1, cosec² θ minus 1 would be equal to cot²θ. So this will be equal to 2 cosec⁴ on square root of cot²θ. The square root of cot²θ would be equal to 2 cosec⁴. This will be equal to cotθ. So this will be 2 upon sin⁴ multiplied by cotθ would be equal to cosθ by sin⁴. And this cancel. So this will be 2 secθ. So 2 secθ is my right hand side. So this is how this question is done. This is equal to right hand side. So as told you, see, this question has more to do with how good your algebra is, how good your manipulation of algebra is, rather than the trigonometric identity. Trigonometric identity was only used here, that 1 plus cot² θ is equal to cosec². The only thing which is. Now let's do the next question. Next question is almost the same like we have done this. Let's start. Oh, I hope you found this lecture interesting. I have a lot of other lectures also on trigonometric identities. The playlist address is mentioned in the comment section. So, a lot of detailed questions, a lot of detailed lectures on trigonometric identities. So, for example, this is a lecture about 1 hour long where a lot of other trigonometric identities have been dealt with. Have a look at this also. All these lectures are would help you in tackling all kind of board questions with confidence. So best of luck for your exams, and hope you found this useful. Thanks a lot for watching.